All right, activity 4-2, we're looking at angles and angle bisectors. Now, the learning objective is going to be to apply the angle addition postulate, so go ahead and underline that, to find angle measures and use the definitions of angle bisectors to find angle measures. Just like with segments, we are working with measurements. Now, let's look at this example right here. This right here is a protractor. A protractor is used to measure the angle, or the angle measure, of an angle. Now, the protractor postulate is right here. It's very similar to the ruler postulate. If you look at it, it says to each angle there corresponds an equal real number between 0 and 180 called the measure of the angle. So for an angle, it's going to be between 0 and 180. The measure of an angle formed by a pair of rays is the absolute value of the difference of their associated numbers. So again, we have that same thing that we had for segments. To look at what the measure of an angle is, you would take the absolute value of their difference. So sorry about that. Now, when you're looking at this right here, you're going to see that there's also some different notation for angles. For a segment, remember we did this last time, for a segment you have these two notations. This one right here, remember, was saying that the segment AB, where when it didn't have the line, we were talking about the measurement of segment AB, so the length of that segment. Same thing with angles. What you're going to notice is that we have this right here. This right here means angle ABC. Okay, this is what we're used to. This just describes the angle. So for example, if I would tell you angle AOB, I'm telling you to look in the picture and you're looking for this angle AOB. Okay? Now, if I give you this right here with that M in the front of it, that means measure of angle AOB. Or measure of angle ABC, sorry. So for example, all of these right here that have that M at the front, that M means measurement. Okay, that's what these M's stand for. So all of these right here are going to be numbers. Okay? So we're actually looking for the measurement of each of those angles. So let's start with the first one. Our first angle is angle AOB. Now, if you don't know how to use a protractor, to use a protractor, you're either looking at the top numbers or at the bottom numbers. Just look at one of them though, okay? It doesn't matter which one you decide to use. So if I decided to use the bottom numbers for this one, you see how it's going from 0 to 50. So the difference in between those from 0 to 50 is going to be 50. That right there would be your angle measure for this one. Now, if you decided to use the top numbers, that works as well. If you look at the top numbers, we're going from 130 to 180. So from 130 to 180, it is still 50 degrees. All right, let's look at angle BOC. BOC. It's this angle right here. So again, you can either focus on the top numbers or the bottom numbers. Now, if you look at the bottom numbers, we're going from 50 to 90. From 50 to 90 is going to be 40 degrees. Or you can look at the top numbers. We're going from 90 to 130. From 90 to 130, that is still 40 degrees. So it doesn't matter which one you decide to look at. And last but not least, let's look at measure of angle AOC. This angle right here, we're looking at, and you can either look at the top numbers or the bottom numbers. It does not matter. So let's look at the bottom numbers. We're going from 0 all the way to 90. From 0 to 90, that is 90 degrees. Or look at the top numbers. We're going from 90 to 180. From 90 to 180, that is still 90 degrees. Okay? So I want you to take a look at that. Look at this picture right here. You have this angle right here. And then you have this angle right here. And then you have that blue angle. We have 50, 40, and 90. This right here is actually going to be your angle addition postulate. Very similar to what we did with our segments. So we are going to color code these really quick. Let's say you have 116 right here, 116 degrees and 25 degrees. Let's look at this angle right here. And this angle right here is 116 degrees. This angle over here is 25 degrees. So I want you to think about what the measure of that whole angle is, of this angle PQR or RQP like they have right here. To find the measurement of that angle, you would just take those two numbers and you would just add them up. When I add 116 and 25, I get 141 degrees. This is actually the angle addition postulate. Now, the angle addition postulate just says, when you're adding two smaller angles, it gives you the whole angle. When you're adding two smaller angles, it gives you the whole angle. So taking a look at that one right there at the top. When you added 25 and 116, it gave you the whole thing. In fact, if you remember the one on the previous page, you had 40 and 50. When you added 40 and 50, it gave you 90. This is how you're going to write your angle addition postulate. Now, you're going to see most of your questions are not going to give you any pictures, so it's going to be your job to draw those pictures out. Given that point D is in the interior of angle ABC, describe how to measure or how to describe the measure of angle ABC without measuring if you are given the measure of angle ABD and angle DBC. So you're going to just draw yourself an angle. I usually like to make it acute, not quite 90, but getting there. And it tells me what angle in the question. It says angle ABC. Really, the important part is just to make sure that you're labeling your pieces correctly. For an angle, remember that the center letter is going to be your vertex, and that's why I put B right here. Right here in that vertex, okay? The A and C just go on one of those other legs. Now, the other thing that this says is that point D is in the interior, so we're going to put point D somewhere inside, like this. Now, just like segments, between is not the same thing as in the middle. Remember, for segments, we had to differentiate. Midpoint was different than in between. Okay, so same thing here. If it says it's inside, it doesn't mean it's necessarily located right down the middle of that angle. So to avoid confusion, I put my ray, this ray right here, a little bit off center. So don't make it completely in the center. Put it a little bit off center. All right, so for this one right here, just like segment addition postulate, you're going to have three parts. This part right here plus this part right here equals to this whole thing right here. Now, I will say, angle addition postulates is a little bit harder to write, and people tend to have a little bit more trouble with this one, okay? It's a little bit longer, all right? So most people tend to skip actually writing the setup for this one. Let's look at this yellow angle right here. Now, this yellow angle right here, the first thing you're going to do is, remember, we're working with measurements, so I do want to have M, the measure of angle, and then you're going to give that yellow angle a name, okay? Look at the three letters that are used in that yellow angle. We have A, B, D. So angle A, B, D. Plus, let's look at this one right here at the bottom. We have this red angle right here, and this is angle D, B, C. So the measure of angle D, B, C is equal to the whole thing. So the whole thing, you have measure of angle, and now we're going to look at the whole thing. The whole thing is angle A, B, C. That's the whole thing. A, B, C. That right there is our angle addition postulate, okay? Now, this one's not as friendly to some people as the segment addition because writing the notation for it is quite long, okay? It's not as short as that other ones were that we did last class, okay? But it's still the same premise. We are actually going to make a cheat sheet for this one eventually that hopefully would be helpful for you when you're setting up your equations. But let's go ahead and practice with number 5. Number 5 says, use the angle addition postulate and the given information to complete each statement. So the first thing, just like with segments, is drawing your picture. P is in the interior of angle X, Y, Z. So you're going to start by drawing your angle. Draw your angle. And then you're going to label that angle. Well, it tells you how to label it in the name. Really, the important part is the vertex. The vertex is Y. So right here on that vertex, you're going to put Y. Then you're going to put X and Z right here. And then it says P is in the interior, so it's inside. So it's going to be located inside like this, okay? Now remember, to avoid confusion, I just go ahead and put it a little bit off center. So you notice how that ray right there with the P on it is not right down the middle of the angle. And then if it's helpful to you, color code it. If not, don't worry about it, but let's just go ahead and write everything else out. X, Y, P. So X, Y, P, it's this top one right here, is 25 degrees. And then it says P, Y, Z, so this one right here is 50 degrees. And I did realize I didn't leave myself a lot of room, but that's okay, we'll just write it right there, 50 degrees. Then the measure of angle X, Y, Z. So I'm looking for X, Y, Z, which is the whole thing. So I want the whole angle. So if I want to find the whole angle, well, that means that you're taking these two angles and you're going to be adding them together. So 25 plus 50 is going to be what we're going to be doing for this, which is 75 degrees. Okay. Now, you are going to be asked to write the angle addition postulate, so we are going to practice that. And I know we don't like it, but we are going to practice it. Okay, so let's just do that really quick. And I'm going to be using the same colors to avoid confusion. Okay, so just like I did at the top, my first angle is this one right here. Plus, my next angle is going to be the one right there at the bottom. Equals to the whole thing. I'm going to label it with blue. All right. Now let's write out their names. The measure of angle, and then look at the yellow one. The yellow one is this one right here, and the letters are X, Y, P. X, Y, P. Or you could have put P, Y, X. That would have been the same thing. Now let's look at the red one. The red one is this one right here. Now this angle right here is called P, Y, Z, or Z, Y, P, whichever one. Angle P, Y, Z equals to the whole thing. So our whole angle is angle X, Y, and then Z. That is your angle addition postulate, okay? Let's look at the next one. M is the interior of angle RTD. So we have angle RTD. And then it says M is the interior. So again, to avoid confusion, I just go ahead and put it a little off center. That's M. RTM is 40. RTD is 65. Find the measure of MTD. You can start color coding them if you want. I'm not going to do that quite just yet. So let's do RTM. RTM is this angle right here at the top. This angle is 40 degrees. 40 right there. The next one is RTD. RTD, that's the whole thing. So the whole thing is going to be 65. And the question is asking you for MTD, which is this angle right here, this bottom one. That's what we're looking for. I'm going to put a question mark there just to remind myself that that's what the question is asking for. Now, if I would do this one, you're going to see that you need two numbers that add up to give you 65. So the best way to do that is by subtracting. Let's do 65 minus 40. And that's going to be 15. So the measure of angle MTD, 15, hold up. 25, what am I talking about? 25, okay? So the measure of angle MTD is going to be 25 degrees, okay? Now, when you're working on your questions, again, we're going to write the angle addition postulate. I understand that just because you write it does not mean that you're going to be adding for all of them, but we are going to practice just writing them. So we have this top one plus this bottom one equals to the whole thing. So let's write it out. The top one is called measure of angle RTM plus the measure of angle MTD is equal to the measure of angle, the whole thing, which is RTD. Now, if I was doing this one, you remember how I put a question mark there? You can always replace it with X. And it would look like this. Substitution, 40 plus X equals to 65. Now, if I was trying to solve this one, I would get that X by itself by getting rid of 40. I would do minus 40 on both sides and get X equals to 25. Let's look at C. So with C, it says H is in the interior of angle EFG. Now we're going to start working with algebra. H is in the interior, so again, just pop H somewhere in there. I avoid having it in the middle. It says EFH is 75, so this top one is 75 degrees. HFG is 10x, so this right here is 10x. And EFG, the whole thing, is 20x minus 5. Now, I know they have parentheses, and so we want to add the parentheses. Really what the parentheses are doing is just telling us that all of this is in degrees, okay? So when you're writing it in your picture, you don't need to add those parentheses anymore. You can if you want to, but when we start working, we're not going to write those parentheses, okay? So we're going to write our segment addition postulate for this one. And yes, I know we don't have that much space for this little question, so we're just going to use color coding instead of doing or writing the whole thing, just because I know this is algebra, so we don't have a lot of space. So that plus that first angle right there plus the second angle right here equals to our third angle, which is the blue, the whole one. Okay, now just substitute, just like we did for those other ones. Okay, so substitute. We have 75 plus 10x equals to 20x minus 5. And I just realized I didn't label my blue one. There we go. Okay. And we can color code these too if we want. All right. Then you're just going to be solving for x. Now for this one right here, I noticed that there's no distribution, so move on to your next step, which is getting x on one side. Let me get that x on one side by subtracting 10x on both sides. When I do that, I got 75 equals to 20 minus 10 is just 10x minus 5. And I get rid of that minus 5 by adding 5 to both sides. And when I add 5, and I'm going to work over here at the top to both sides, I get 80 equals to 10x. To get the x by itself, I'm going to divide by 10 on both sides. X equals to 8. Okay? Now, just like segments, read your questions carefully. If it's just asking you for x, wonderful, we'd be done. But it's not. This one's actually asking you for the measure of angle HFG, which is this one right here. Oops, sorry. This one right here. So we're going to take that 8 and put it in there. So the measure of angle HFG is going to be 10, and instead of x, we are substituting in that 8. So 10 times 8, which is 80 degrees. 80 degrees. All right.